The topic is find the limits of functions of two variables. So let's do the first example. Show the limit of xy over 5x squared plus y squared as xy approaches 0, 0 does not exist. So let's read the definition. If limit of f of xy as xy approach ab along path c1 is not equal limit of f of xy as xy approach ab along another path c2, then we say limit of f of xy as xy approach ab does not exist. So any two paths will work. Of course, two distinct two paths, two different paths. Alright, so now let me call this function f of xy. So f of xy is equal xy over 5x squared plus y squared. So along generally we use these paths. Y equals 0. In other words, x-axis, x equals 0. Path x equals 0 is what? Y-axis. And then y equal alpha x. Y equal some number times x squared and x cubed and so on. Not only that, we can also choose x equal alpha x and then x equal alpha x squared, and if we need x cubed we might need x fourth and so on. Alright, so here let's pick, for example, along a path along the, let's find the limit along the path y equals 0. So that would be what? The limit of f of xy as xy approach 0, 0 along the path y equals 0 is equal to, what does it mean y equals 0? X-axis means limit of f of x y equals 0. So I'm replacing y by 0 as xy approach 0, 0. Now what is that? F of x 0 means wherever you see y, you plug a 0. Right? You plug a 0 here, plug a 0 there. This will be a limit x times 0 over 5x squared plus 0 squared as, x. So all we need now, it's a function of x, so we want x to approach 0. So it becomes like doing limit of a function of one variable. Now this is going to be equal limit 0 times x is 0, 5x squared plus 0 squared is 5x squared as x approaches 0, and this is just equal to 0. That's the simplest limit. So from along the x-axis we know that the limit is equal to 0. Now let's check, for example, if we do x equals 0, then we'll get a 0. So let's do, for example, y equal, generally, if you look here, generally what the way to get another number other than 0, if you plug x here, you'll get x squared plus 5x squared in the denominator, which is 6x squared, and the numerator you get x squared. So you'll get a number. Let me show you what I'm talking about. So in other words, I'm going to do limit of f of xy as xy approach 0, 0, but it's along y equal x, and I'm going to show you why I choose y equal x. I want to get a number other than 0. This is going to be equal limit of f of x, we said y equal x, as x approach 0, or just x approach 0, because this is a function of x. This is equal limit as x approach 0. Wherever you see y, you plug x. You plug x here, you plug x here. So you get x times x over 5x squared plus x squared, which is equal limit of x squared over 6x squared as x approaches 0. Simplify this and you get 1 over 6. So therefore limit does not exist because along two paths we don't approach the same number. So limit of f of xy as xy approach 0, 0 does not exist. So remember, it's really easy to get a number other than 0. Just think about this. You want to plug a number, you want to plug an x. If you plug an x into y, you get 5x squared plus x squared, and then the x squared gets simplified. So again, what do we do here? Well, here's another example. So let's try to choose a path where we get a number, the limit will be a number other than 0. See, I'm looking at this. I see x squared. I want to have plus 6x squared in the denominator so I can get 7x squared. So I want my y to be what? X. Right? So same thing. X squared. Right? So x squared plus 6x squared will be 7x squared. So what I do here, I'll do a limit as xy approach 0, 0 along y equal x squared of f of xy, and this is going to be equal limit of f of x squared, right? I replace y by x squared as xy, well not xy, x squared approach 0, 0. We could have just said x approach 0, which is equal limit as x approach 0. And now all I need to do, whatever I see x, I'm gonna plug. Whatever I see y, I'm gonna plug x squared right here. So that would be x squared over x squared plus 6 times, I replace y by x squared. And this is gonna be an easy one. Limit of x squared, 6x squared plus x squared is 7x squared. As x approaches 0, simplify the x squared and you will get 1 over 7. Now to get a 0, for example, it's easy, just plug in x equals 0. By the way, you can even do y equals 0, you'll get 1. Let me show you two different ones, even though all we need is two paths. So let me do x equals 0. Limit of x as xy approaches 0, 0 of f of xy along the y-axis means x equals 0 along x equals 0 will be equal limit of f of x. Whoops, the x is 0, so 0 y as y approaches 0 this time. Now whatever I see x, I'm gonna plug a 0 here, plug a 0 here. That would be 0 squared over 0 squared plus 6y, and limit as y approaches 0. And this is gonna be limit of 0 over 6y as y approaches 0, and that's just equals 0. Now this is enough for, we have two different limits, so does not exist. So limit does not exist. But if I want to just show you, because I just noticed that you could have choose also this path. Limit of f of xy as xy approach 0, 0 along the path y equals 0. This will be equal limit of x, limit of f of x 0, right? The y you want it to be 0, and then as x approaches 0, which is equal limit, whatever I see y, I plug a 0, so x squared over x squared plus 6 times 0 as x approaches 0. Now this is a limit, x squared over x squared as x approaches 0. You simplify this, you get a 1. So here's another one, even though you only need two paths. Alright, let's move on to example 3. Oh, again, as soon as I'm trying to show that limit of 7y squared over 3y squared plus x does not exist. So as soon as I see this, if I want to get a number, an easy number that's not equal to 0, an easy limit, I let my x equal y squared. So limit, again, this is my f of xy. So limit of f of xy as xy approach 0, 0 is equal limit. So what do we do? Along x equal, now you want x to be equal y squared. So along x to be equal y squared. So that would be 7y squared over 3y squared. Whatever I see x, I'm going to plug y squared plus y squared. And then I want my y to approach 0. Now this is going to be limit 7y squared over 3y squared plus y squared is 4y squared. As y approaches 0, simplify the y squared and you get 7 over 4. Now all the other ones you'll get most likely 0. Well, actually, if you let x equal 0, you'll get 7 over 3. So you can do that, or you can do, yeah, let's do that. That's an easy one. If you let x equal 0, so limit of f of xy as xy approach 0, 0 along, hold on, make sure. Yeah, make sure the domain, for example, the domain for this one, you want y squared not equal to minus 1 over 3x. So you cannot use a path y equal negative, well, that's y squared. So, well, that's an easy one. So x and y cannot be 0, 0. So the domain will be only, well, no, square root of y squared. Square root of y squared. You don't want this. Let's do equality. Yeah, you just don't want the 0, 0, so it's fine. Alright, so along x equal, yeah, you just don't want the point 0, 0 in the domain. Now, limit of f of xy at xy approach 0, 0, we can do this along x equals 0, y-axis. Now this will be equal limit of whatever you see x, you plug 0, so 7y squared over 3y squared plus 0 as y approach 0, and then simplify this and you get 7 over 3. So therefore limit does not exist. They are different as xy approach 0, 0 does not exist. Alright, last example. Example 4, limit of xy4 over 2x squared plus y to the 8 does not exist. So again, as soon as I see this, I want my y to be what? Or my x to be what? If I put the x to be 4, if I let x to be y, if I let x to be y to the 4th, right, then x squared will be y4 squared, which is y8, right? So let's do that. The reason why I choose x to be y to the 4th, because I notice if I plug it here, I can add these two. Same trick. So limit of xy4 over 2x squared plus y8 as xy approach 0, 0 along x equal y to the 4th is equal limit. Now whatever I see x, I'm going to plug y to the 4th. So y to the 4th and then y to the 4th. So I plug y to the 4th here. Then I will need to plug it here also. So 2y4 squared plus y8, and this is going to be y approach 0. This will be equal limit y4 times y4 will be y8 over 2y8 plus y8 as y approach 0. Now this is going to be limit of y8 over 2y8 plus y8 will be 3y8 as y approach 0. Simplify or cancel, and then you get 1 over 3. So I got number other than 0. Now next one, you could just use y equals 0. It'd be easy. So limit of xy4 2x squared plus y8 as xy approach 0, 0. Now I'm going to choose the path along y equals 0 or x equals 0. Both of them will work. Now this is going to be equal limit. So whatever I see y, I'm going to plug a 0. And of course the x approach 0. Limit 0 times x is just 0 over 2x squared plus 0 will be 2x squared as x approach 0, and this is just equal to 0. Now of course these are not equal, therefore limit of f of xy as xy approach 0, 0 does not exist. And of course we're calling this to be my f of xy. Right, you could also choose, let me see, yeah, it doesn't matter. If you choose x equals 0, you're also going to get a 0. Alright, 0. Alright, that's it for this example.